Okay. Last night I posted on Teams. Did you see it? Okay. So, it's because I didn't tag you. So if I tag you like this, it should give you a notification on the sidebar. Is that right? When your teacher tags you? Alright. So on Teams, if you ever miss a class, I will upload a recording to YouTube. So yesterday's class was recorded. I'm recording now as well. Okay, so turn it off. It's really weird hearing my own voice coming out of another computer. All right, so that's there. Okay, so just to give you a little bit of background, um, we're actually starting with one of the more. I'll just wait for the back. Emily, Maddie. So we're actually starting with one of the more difficult topics in general maths, linear equations. The reason for that is, number one, it's needed in every other topic. And number two, if for whatever reason you think that general might be too difficult for you, we'd rather that you find this out early on. So that's why we've started with this topic. If you find this topic too difficult, just come and let me know, and we can discuss whether you keep going or you might consider foundation maybe in semester 2 next year. But I promise you, this is not a class about algebra, although it might feel like that for the first few weeks. All right, so if you want to take notes, please go ahead. I believe you've been doing this since year 7, solving linear equations. So we're about to do a few examples. If you can see that? Yeah. All right. Guys, we're going to zoom from year 7 to year 10 in one lesson. Okay. Have a look at this equation that I've written here. X plus 9 equals 15. I think you can probably just tell me the answer without needing to do any working. What is the answer? It is 6. Okay. Imagine I asked you, what do you need to do to both sides of the equation to get x on its own? Take away 6. Now, from what I've observed at this school, you actually learned it differently to how I learned it. So I've seen Mrs. Collins do this. I've seen Mrs. Marchetti do this. They show they're working out by writing minus 9 on both sides. So what we're trying to indicate here is that this means minus 9 on both sides. I like to think of these as training wheels. Once you become very experienced with algebra, you don't need to do this step anymore. But if you don't feel confident, it's perfectly fine. So why is this a good idea? 9 minus 9 gives me 0. So on the left, I will just have x on its own. So the 9 and minus 9 are cancelling each other out. And then that's right. Okay? So the advantage of this approach is that we don't have to guess the answer by looking at it. So for example, if I change the numbers to something where you can't do it automatically, you can still get the answer. So for example, if I gave you an equation like this, just gotta wait for this to stop glitching. Exactly the same idea. What should I do to both sides of the equation to get my answer? Minus 1.23. So I'm guessing it's not so clear what the answer is here. Okay, does this match the way you've been taught to do algebra over the last few years at this school? So those of you who had Mrs. Collett this year, did she tell you to do this? Yes? What about Mr. Kite? What did Mr. Kite do? Okay, maybe we won't go there. Who else have you had? Who taught you in year 9? How did Mr. Mawson show us working out? You did this? Okay. All right. So we only have one exercise on algebra, but it's kind of sitting underneath all of general maths the whole time. So in order to do well next year, you need to be able to rearrange equations. Just linear equations. So nothing nonlinear, no factorizing, no quadratics. Okay, so if you have nightmares from year 10, all that stuff is not here. But some basic algebra, you want to know this. So sometimes this is called the balancing method. All right. We're going to do quite a few examples. We're going to build up. So I've got about 3 or 4 pages worth. All right. So we've already done something like this. All right. What about the second one? What should I do to both sides to get rid of the minus 8? Plus 8. Why should we plus 8? Very good. So the language you might have used is inverse. Inverse is just another word for opposite. Operations. So for example, if I plus, the opposite is minus. If I minus, the opposite is plus. What's the opposite of timesing? Excellent. Okay? So notice that these operations are coming together in pairs. So as soon as you see a plus and you want to get rid of it, you minus. If you see a minus, to get rid of it, do a plus. All right, 5x. Talked a bit about this yesterday. Remember, what does 5x actually mean? 5 times x. So how can I isolate or get the unknown value of x here? Divide by 5. Very good. Okay, and the last one, what should I do? Yep, times by 6. So remember, when we write a fraction, I know fractions can be an issue. This thing means x divided by 6. So whenever you see a fraction, division is happening. So to undo the division by 6, I want to multiply by 6. Okay, so in my view as a maths teacher, the most important part is the black writing. It's what you're actually doing to the equation. I don't really care about the answer. What I care about is the thought process that gets you to your answer. Because if you have the right thought process, but you make a small mistake, that can be fixed easily. But if you give me the correct the correct answer with no working, I don't know whether you understand anything or not. So I'd rather you do the black writing than just the answer. All right, and you're always allowed a calculator in this class, so don't worry about doing these things in your head. Okay, so that's year 7. You okay? All right.
Wait, that's E7?
I think so.
There's no way.
I haven't taught year 7. I'm pretty sure that you do.
I'm doing something.
So these are called one-step equations.
I remember doing it here.
Okay, well, you probably did it again in year 9. So I did this in my year 8 class. In year 8, we do two-step equations like this. Okay? All right, so no matter where you are starting, if you want to start here, go for it. But we're going to work our way up. So now we're in year 8. Let's look at the first equation. It's going to get harder to just write down the answer. That's why I'm emphasizing the working out or the black writing, the step that you're performing on both sides. So by this point, there's more than one way to do a question. So what would you like to suggest doing here? So Jess suggests plussing 12.
And then divide.
Okay. So watch what happens if I plus 12. We get 2x equals 32. And now I've got a one-step equation, just like the ones on the previous page.
Is that right?
Hmm?
Is that like how to do it?
Yes.
Yep.
I just want to make sure I write it down.
Yeah. Sometimes I will debate you. I'll write something down and I'll correct it. So, but I'm not going to do that this week. At least I don't think I will. All right. Someone from the back row. What would you like to do for the second question? 3x plus 10 equals 25. Top right.
Take 10 from each side.
Take 10. All right, let's see what happens. Are we closer to our goal? Very good. All right, while I get Tully set up, why don't you have a go at these two questions? So there's one with brackets. You might need to recall what you did with brackets. And one with a fraction. So I'll give you a couple of minutes to try those two questions down the bottom. And just let me get Tully set up.
Where do I get this from? Is that just this from? But X, so I can't put X right. So I can't make it green. And then I realize that take it then like
Well, we're going to do it now, so don't worry too much about it. All right, year 11s. Let's talk about it. So, I'm actually going to start with the one on the right because I think it's easier. The brackets add another layer of complexity on top. What do you suggest we do with x plus 4 on 7 equals 3? First step, what should we do? Times by what number, Clayton?
7.
All right, AJ says 7. All right, if we do this, what will I have on the left?
X plus 4 equals 1.
Remember, you've got to do the same thing to both sides. X plus 4 equals 3 has an error. 3 times 7 is not 10. 21.
Emily said that first just now.
Yeah, and then minus 4 on both sides.
Very good.
That would be correct.
So, just as a reminder, year 11s, if I want to quickly check whether I have the correct solution to my equation, take the number 17 and put it back into the equation. 17 plus 4 is 21. 21 divided by 7 is 3. So it satisfies or makes the equation true. All right. I haven't told you how to expand brackets yet. You don't need to expand the brackets here. You can if you want to. I'm about to do that on the next page. But we can actually do this without expanding the brackets. Can anyone see how? Sorry, say that again?
Isn't it 5 times x? Take 5 times 3.
Okay, so that's expanding the brackets, which is totally fine. All right, so I'll solve it here. Okay, so that's if you expand the brackets, which I haven't told you how to do yet. What if we don't expand the brackets? You can't plus 3. Not quite. Divide by what? Did you call it BODMAS when you were at school? Order of operations? So imagine I start with the number x. What happens first? Do I subtract 3 first or do I multiply by 5 first? I hope this won't give me a new tab. Yes. Okay. Okay. I don't know if you did flow charts when you did maths. Imagine I start with the number x and I take away 3. How do I write down the final expression that I have? Now, minus 3x is if you multiply by x minus 3 is correct. Now, take the whole thing, Kalisha, take the whole thing, x minus 3, and multiply it all by 5. How do I write that? Okay, 5x minus 15 is one way. Is there another way? When I write a number in front of brackets, that means multiplication. Is that familiar to you? Okay, so If I go back, don't know the shortcut yet. I wonder if it's Control Tab. So here, I've started off with x minus 3, put it in brackets, and then I've multiplied by 5. If I go back now, imagine I multiplied by 5 first. What will be the expression that I get this time? 5x. And then take away 3. No, I want... it's Control Tab here. Alt Tab is to a different application. Okay, so is that clear? Brackets, number out the front, means multiply. Okay, I don't want to belabor the point, so let's go back. All right, so if I divide by 3 on both sides, divide by 5 on both sides, this time I'll get x minus 3 equals 4. You know how to solve this now. Plus 3 on both sides. X equals 7, which is the same as what we got before when expanding the brackets. Okay? All right, so whichever way you are more comfortable with is fine. All right, I'm just gonna do these for you. So again, you don't need to expand the brackets. If I divide by 2 on both sides, I get rid of the 2 out the front. I think if we do this as a class, this will take a bit too long. So you can get this down if you wish. Okay, are you comfortable with me saying if I have minus 2x equals 18, I should divide by negative 2 on both sides?
Yeah.
Negative numbers have also caused issues. What does it mean to divide by a negative number? If you don't have a calculator, that's okay. Do you know what the answer is going to be if I divide 18 by minus 2? Correct. All right, so I'm going to put a small note down here. Positive times positive is positive. Negative times negative is positive. Positive times negative is negative. And negative times positive is negative. Yep. Those year 12s are spying on our class. All right, positive divided by negative is negative. Negative divided by positive is positive. No, negative. Negative divided by negative is positive. And positive divided by positive is positive. All right, guys, hang in there. I know it's a bit long. I'm hoping it'll take about 10 more minutes. All right, so let's look at this equation here. 20 plus 3x equals x. What's different about this equation to all the other ones we've done before? Okay. X is also on both sides of the equation. So now we're entering sort of year 9 territory now. What should we do here? cancel x's. So what operation do you want to do to both sides, Ben? Divide by x. So from my experience, dividing by x will not help us. Divide by 3. You got something better. Minus x on both sides. Very good. All right, watch what happens if we do this. What will we get on the right-hand side? X minus x, what's that? X can be any number, but x and minus x are inverses. Okay, 3x minus x, what's that? 2x. You're collecting like terms. Is that a familiar phrase? Okay. Common error. What haven't I done? So it happens pretty often. So make sure that you include everything in the equation. Okay. What should I do now? Okay, you can do that. No, this looks good. Very good. Guys, just let me know if I'm going too fast or if you can't see the screen. Because I know my head's blocking it. Yes, I can leave it there for 30 seconds. Yes. Okay, Emily and Maddie, can I move now? No. Okay. Thank you. All right. I could just have everyone's attention to Jess, Emily, Tully. Okay, so now I'm just going to remind you how to expand brackets. So many of you already know how to do this. Put it in words for me. If I give you two numbers in brackets and I put a number out the front, what should I do to get rid of the brackets? Great. So when I was at school, we drew arrows to help students understand. So you do B times A and C times A. Well, they're the same because multiplication is symmetric. Okay. When I do stuff with letters, does that make you uncomfortable? So let me just remind you with numbers, okay? Three plus 7 is 10, and 10 times 2 is 20, right? So if I expand this using our method, I could do this. 2 times the first number plus 2 times the second number, which is 20. Or you could do 2 times 10 is 20. Either is fine. Okay? Yep. This is the picture. It's still fine. This will always work. Guys, if I get everyone to quieten down. Did anyone draw a picture like this with the rectangle there? No, as in like when you were learning about algebra. So which teacher was this? Okay. So you could have a 2 by 10 rectangle like this. Area is 20. Or I could split it into 6 plus 14. Also giving me 20. This is a visual representation of expanding brackets or the distributive law. Okay? So I can split 10 however I want, but I can still multiply them and add them back up and get the same answer. All right? But if you don't want to go through all that, you can just memorize the rule, which is what I did when I was at school. All right, so let's just do a few examples. 2 times, this time I've got an x. X plus 3, what's my answer going to be? Very good. All right. Someone different. AJ, what do you think?
5x minus 10.
Great. Mac? Let's see. Jackson, what do you reckon for the last one here?
Take away 16 minutes.
Very good. Very common error is to only multiply the first term. Make sure you multiply both terms inside the bracket by the factor which is on the outside. Okay? So for example, in the first question, 2x plus 3, very common error. You want 2x plus 6. All right, in the interest of time, let's just do the second question here. I will do this one for you.
Have you ever thought about going to something else?
No. Okay. No, because you're going to do it.
6x minus.
Wait. Now, if you can get this question, that's as hard as algebra will ever be in this class.
Oh, really?
Okay? So it will, I promise you, it will never be any harder than this over the next 2 years. It'll look different, but algebraically, nothing harder than this. So, if I give you this question and I ask you to solve the equation, what should we do? What would your strategy be?
6 times x and 6 times 12.
Okay, what has Ben done here? Yes, he's done maths, but if I were to describe the step, what was Ben's first step here? Say that again? He's expanded the brackets. What's the second bracket going to be? Yep. Okay. Question for all of you. Was it helpful to expand the brackets?
Yes.
Why? How does this help us get towards our goal? Getting the like terms, okay. All right, so how do we do that?
6x and 8x.
All right, so what are you going to do to both sides of the equation? If you take x, you'll still have x on both sides. Take 6x. All right, let's try that. So as you become more experienced, you'll know what will work. So my experience is telling me you can either take 6x or take 8x. from both sides. John?
In the second question, when it says 24 plus 2x, shouldn't it be 12x?
24. Oh, thank you. Thank you.
Let's go.
Thank you. I know. I'm too lazy. Actually, with the power of technology. All right. 12x. So guys, did you see what happened there? I made the error. I only expanded it on the first thing. I didn't do it correctly on the second thing. So minus, let's minus 12x. Huh? I did what too fast? Yeah, that's what that is exactly what happens when you do things too quickly. You make errors. All right, back to this equation now. Minus 12 equals 2x plus 2. I think we're nearly there. What should we do? Take away 2? Why is that going to get us closer to our goal? Very good. Last step, what should we do? Because we've got 2 times x. And that was a brief tour of all the algebra that you need for this class from year 7 all the way up to year 10. I would say this last question is a year 10 question. All right, because you've got 2 brackets to deal with here. Yep. Now, I'm about to release the hounds, that is you, to devour some algebra. Now, before I do that, do you have any questions you want to ask me? No questions? All right. Please make a start on exercise 5B. Refer to your work program. Go get it.